All right, welcome over to week 7, day 1. We've been talking sort of offline here about CSI 26. That's third semester computer science. It's discrete math. It's taught as literally a math class at a lot of institutions. When I took it at UC San Diego, it was 2 quarters, and there was no programming in any of it. It was just purely math. Like I would just go to the local coffee shop and get a Strawberry Fields, which is an amazing blended coffee drink with some strawberries added to it. It's incredible. And I just sit there and drink my coffee and just do page after page after page of math every Tuesday and Thursday, And I don't teach it that way. The way that I teach it, it's half programming and half math. And so part of the reason for that is like, I feel like you learn things better when you actually code it up, right? And so when you actually implement RSA encryption or something, like you tend to remember it a little bit better than if you just kind of read about it. So, some poor schmucks have taken as a junior. Yeah, we have pretty good enrollment in 40 and 41, but a lot of people also transfer, the second year and stuff like that. So they take a year of community college and they transfer out and stuff like that. So typically there's a drop off in enrollment by 26, but if you've had me for 41, then you're going to be pretty well prepared for 26. And it also allows me to just kind of continue that process of like expanding your minds as far as programming goes. Like you start off in 40 and you're like learning with for loops, and then in this class we have for loops inside of for loops inside of for loops, and just kind of over time like your brain just kind of like grows, and it's sort of a deliberately designed path that I've kind of created so that if you take me with 40 and 41 and 26 and then 45, at the end of it you're like pretty good. You're going to be a pretty good programmer by the end of the thing. AP classes are harder than college classes. I don't know about that. Okay. So anyhow, this is Ginzan Onsen in Japan here, if you're wondering. All right. So what we're going to be doing is we're going to be giving you your next homework assignment today. Now, EU4 is due on Friday. I'm going to actually give you your next homework assignment today. And the reason for that is because it's a really easy homework assignment. And I'm going to give you 9 days to do it anyway. So on Friday, we're going to be talking about big O notation, things like that, which is a really important topic. But I kind of have seen that a lot of people are done with EU4 already. And we'll do a little bit more with linked lists. It's a really easy assignment. Like you don't need to really worry about it too much. Let me show you what it looks like. So this is going to be doing a little thing. Let's see here. See, it is earthquake dot reference. So the way that's going to work is this: you run the program, and it actually gives you a URL. And so what the program does is it grabs from the U.S. Geological Service the 100 most recent earthquakes, and then visualizes them as a linked list in order of date, basically. And the visualization is using the magnitude and location. Let me show you what it looks like here. Yay, data science-y kind of stuff here. And what we got here is a earthquake, a 1.0, 1 kilometer north-northwest of the geysers in California. Another one in the geysers, California, Cobb, California, Hawaii, Alaska. There's a 4.7 in Panama. 4.2 in Chile, 4.5 in Vanuatu, it's a Pacific island, 5.4 in northern Colombia, so 5.2 in Japan. That's not good. I was in Japan during a major earthquake, and that was unpleasant. I was there during a 7.1 in Kyoto, and my daughter and I were walking down the street, and I hear the roof just like rattling, and it is like, Daddy, what's that? I'm like, I think somebody's like running on the roof or something. She's like, I don't think so, Daddy. I think it's an earthquake. I'm like, no. There's somebody running on the roof, because it's really sound like. And then I look around, and all the Japanese people are like sitting there with like these worried looks on their face. I'm like, oh, traffic comes to a complete stop. I was like, oh, it is an earthquake. And yeah, it was actually a pretty major earthquake when I was there, and shut down the whole train system. We were supposed to leave Kyoto that night and go to Kinosaki Onsen, and couldn't. I had to call up the ryokan we were staying at and be like, yeah, we're stuck in Kyoto. Sorry, like we understand. Don't worry about it. And all the elevators were shut down. Like, and people have to come through one at a time, and they inspect every mile of track, every elevator, like everything. And it was a wild experience. So AP Euro is the only class you got an F in. I like AP Euro. It's a fun class. So yeah, so what this thing is doing here, it is visualizing the 100 most recent earthquakes around the world. And you can see the color is based on the magnitude. So we got some 4.4s, 4.5s. So 5s are bigger or purple. Yellows are in the 2 range. Greens are in the 1.5 and up range. Under 1.5, you got blue here. Oranges are 3s. And let's see. Yellows are 2s. So a cross means that it is in Hawaii. A diamond means that it's in Alaska. And a circle means elsewhere. And you can see that the size of the dots get a little bit bigger too. So 1.8 is a little bit bigger than 1.1. That's what you're going to be doing. That's your homework assignment. And the good news is it's almost all done for you. As far as like the linked list goes and the visualization, all that stuff, it's like pretty much done for you. You just have to use a linked list. You don't have to like really build a linked list like you're doing with EU4. So it's quite a bit easier than the EU4 assignments. In fact, you should be able to finish it. Then, like the first half of it should be 10, 15 minutes, maybe, something like that. Okay, so in order to do this assignment, though, you need to register on the Bridges website. So Bridges is Bridges, UNCC. Yep, that's the wrong Bridges at UNCC. Here we go. There we are. And paste here. So I've been working with the Bridges people for years now. There are a lot of great people out there. KR and Eric Sully are really sharp individuals. They're professors who are kind of heading up this project. People hate on Bridges. You think it's neat? I think they're just more afraid of the assignments than the Bridges part of it, because the Bridges part's like pretty easy and straightforward. So what Bridges is, here I'll just play this video.
Bridges is an API that allows early computer science students to create interactive visualizations as early as their first programming course.
The primary motivation was to improve the retention in computer science. We lose about 40%. So the idea was that we want to do something that would improve the retention in computer science majors.
It enabled students to actually have access to real-world data inside of the classroom. So that when they do assignments, they can do assignments on data that they care about.
We abstract a lot of the heavy lifting visualization tools, and it allows for the viewing of these abstract data structures within your web browser. It's easy to access and to see what you've created rather than just looking at text and letters.
It's not just, hey, I painted a pretty picture of my data structure, they're actually interactive. You can kind of reshape the graph using the mouse, using touch interactions, and highlight different things that are interesting rather than just having one picture generated.
The newest feature in Bridges is Bridges Games. It allows students to learn basic programming concepts while creating games that work not only on the web-based system, but on their phones as well.
Bridges Games is going to be a breakthrough for Bridges. It's going to allow us to reach lower level students below CS1, but also reach students above CS2, which could be AI.
It's actually easy for instructors in Bridges to develop their own learning material. In my parallel computing course, I have written a library that students can use in order to learn more about functional dependencies inside of algorithm. By using it, they can understand how the dependency structure of algorithm look like, so that they can figure out how to make them farther.
So over a period of 3 semesters, we actually followed computer science students and measured their learning gains, knowledge gains from semester to semester. Secondly, we also measured how well are they doing in computer science after they've taken this course in data structures. And so one thing we have found is when you did control studies, that the students who went through this course with Bridges were passing at a higher rate and with statistical significance.
We've been increasing our user base of people. We've reached and worked with on the order of 1,000, 2,000 students now across some different institutions in the country.
Bridges has been
That's us.
successful so far. It has been successfully deployed in many classes at UNC Charlotte and across the United States.
So what you need to do, yeah, they put us in New Mexico instead of California. It's kind of funny. So what you need to do is you need to go to the Bridges website, and I will post this link again for you. So you need to go there, and then in the top right corner, there is a login button there. Click on that. Click on login if you have a password. If you don't, sign up for it. I'm sure you all know how to do website registrations by now. So you need to create an account on there. And what it's going to give you is a username and an API key. Now, you probably don't have all the projects that I have here. This is, what is that? That's routing here in Fresno. So this is grabbing Open Street View maps. And so this is going from like, what's that? That's the 41 there. That's Friant. So it's like routing from like Fresno and Shaw, maybe? Fresno and Herndon over to our campus. Something like that. So there's a lot of cool things you know with Bridges. And basically what it's all about is being able to visualize data structures, right? So, you know, like when I've been teaching y'all linked lists and stuff like that, I said, you know, it really helps if you have like a graphical representation so you can look at it and kind of see what's happening. And so, for example, here is a circular doubly linked list, and you can see that all the arrows are kind of linked up and pointing the right way. If I had screwed this thing up, there might be an arrow going from like here to here or something, you know, and you can actually literally see it that you screwed up. Whereas a lot of you that are screwing up on like EU4, it's like, I don't know why, you know, like, and you know, you have the code, and in the code, you think you do the code correctly, but it's not correct, and then it doesn't work, you're not really sure why. And so Bridges is about trying to bridge that gap between like the code and like the visualization and things like that. So is that the Dijkstra's assignment? That was one of the Dijkstra's assignments. I've got lots of them. And so for this one, it grabs actual street data and then does a Dijkstra. So you can say traverse from this street location to this street location. It actually does like a Google Maps and graphs it for you and stuff, which is pretty cool. For this assignment, you're going to be doing a singly linked list. And the data is going to be coming from the U.S. Geological Service. Yeah, so let's go. Yeah, I'll just show you my API key. Why not? I'm going to change it in a second. So after you create your profile, you're going to have a username and you're going to have an API key. Okay? And when you do the assignment, what you're going to do is you are going to punch in your username here, where it says username. That's going to be W. Kearney for me, whatever your username is. The API key, which is a string, by the way, not a number. Copy and paste the thing inside of there. So you do copy, paste, like that. There you go. And then after you get your username and your API key typed in, delete that line of code. This line of code here is a static assert false, which means do not compile this code. The compiler will look at this and be like, eh. And you try compiling the code, it says you must register on Bridges first. So once you got all that in, then it will, then just delete that and you're going to be good to go. The project ID doesn't matter. It's kind of like a save slot on a video game. So every time you run the program, this is going to go into slot 1002. You can call it slot 1 if you want. And every time you upload, every time you run the code, it's going to go into slot 1. It's going to overwrite the old one there. If you wanted to, you could be using slot 1 for a while and then do slot 2, and then you'll have two different projects up on the Bridges website like so. So this is slot 1, slot 3, slot 4. This one's slot 1005. So every time I run my Bridges Earthquake thing, it uses project ID 1005, as you can see on the left-hand side over there. And it will overwrite the old one. The actual project ID does not matter. It's just purely you know, what slot you're saving to. Okay, so let's go through this. So you're going to punch in your username and your API key. Let me go generate a new API key now real fast. So you click on the new generate new API key button there. and copy, and we'll just deal with that later. Okay, so you punch all that in here, delete the static assert, then it's good to go. You should be able to compile it and run it. It should work fine. Now, let's just go through this line by line so you understand what's happening here. So this is a class called Bridges that they made. I didn't make this code. They made it. The UNCC people made it. And it basically punches in your project ID, your username, your password, API key. And that does the connection to the server for you. You don't have to know any networking on this. You don't have to know any visualization on this. It just does it for you. It's nice. This sets the title. The title is going to be right here. So set that to whatever you want. You know. Then this code here is going to be interesting. They don't have. It's interesting they put the std on there. I don't think. I think they're using namespace standards, so I think that's a little bit excessive. Okay, so data source. So they've got this really interesting setup where they have a data source object that can feed you data from actually a wide variety of data sources. So in this case, we're calling the get earthquake USGS data 100. And what this does is it connects to the US Geological Service and grabs the 100 most recent earthquakes in real time for you. And you don't have to know anything about it. And it returns it in a vector. So it gives you a vector of earthquake USGSs named earthquakes. Okay? And earthquakes. Do we already have one of those? Does that work? I'm not using earthquakes anywhere else? Okay. Okay, so that might make it a little easier for you to read. Either way. So, what is an earthquake USGS? It's basically a class that they have made that describes an earthquake. It's got let's actually look at it. Okay, so here we have a vector of earthquake USGSs. And we want to find out what's actually in that thing, right? This is actually a very common question we ask, especially when you're dealing with a new code base, right? Has anyone here used grep before? Grep. You tried? Okay. So, like, if I was in a new code base, and this is very common, like you're just in some code base and you're like, all right, where the hell is this thing, right? Where is this defined? The first thing I would do is I would do this. I do grep shift insert star. And this is going to look for that thing in all of the files in the local directory. Hey, that's useful. Grep is one of those power tools you have to know as you become an experienced professional programmer, because in college and these toy assignments we've been doing where they're all in like one little file, you don't need grep. You can just open up your one file that has everything in it and use / and vim and search for things. But in real projects, like if we go into the Quake server thing here, there's a lot of files in there, right? All right, where is the convex hull found? I know they have convex hulls somewhere within this source code here. I don't know where, right? So I use grep. Star means every file. Okay, so I'm going to grep for hull in every file inside of here, and this is going to give it's like a find across files, find in files. So this is going to return in every single file in this directory. That's what the star means. Anytime the word hull appears, and if I was actually working on the Quake code base for realsies again, In fact, I have. I do greps all the time. I'm like, where the hell is this stuff? You know. And if you're using like Visual Studio or something like that, Visual Studio has the ability to like right-click on something and be like, go to definition of the struct or whatever, which is really nice. But if you're a Vim/Linux user, there's a number of tools like grep that search across all .c files. Okay, search across all .h files. Okay, there we go. So it's defined there. /whole and whole t structure. This change, it must be changed there too. Oh, interesting. Yeah, this is for assembly. Oh, that's interesting. So grep whole _t. Interesting. Yeah. So you can see every place where this word appears, right? And so the whole T there. And so, where is it? Is it just defining that .h file? So weird. It might be in a different directory. Either way. There we go. There's where it's defined. Yeah, it's in a different directory. So these tools are used to search across different files, find where things are, get an idea of where it's being used, who's using it, that kind of stuff. Grep is one of the most important Unix utilities you need to learn, because it helps you like explore an existing code base. Like when you go to work for a company, they're going to have an existing code base, and using grep allows you to find where things are in different directories, and there's a lot of options, and allows you to narrow down and find every time something's used, see who's using it, see where things are defined, things like that. So coming back to my earlier point, earthquake, let's see, bridges. It's like we were trying to find this USGS thing, right? And it's referred to here in main.cc, but it's not defined in any of these things, right? So it's like, okay. So it's probably located within data source, probably, because that's where we first heard about that. So we're now going to locate data source.h, and there is data source.h. It's in user/include/data source.h. These are local copies that I have. This is the one. User include is where the official system installed headers are. So I've got a version there. So I'm going to vim that file. And I'm going to search for USGS, and there is in fact a file called data source earthquake usgs.h. Cool. Locate that file. And there are you, vim u. Let's try that again. Vim, jeez, okay. Vim u. And there we go. So here we have what is it? Star. Yeah, it's an pointer. So here we have the actual definition for the earthquake USGS thing. Okay, and the actual amount of time it would take me to find something like that is actually fairly small, right? you can usually locate where things are using a combination of grep and locate and things like that pretty easily. I'm just kind of showing you so you can kind of see how the process works. So, what is a earthquake USGS? It contains information on a magnitude, the latitude, longitude, the location, like Hawaii or whatever. That's the combined title, like 5.5 off Vanuatu, whatever. URL for more information and the time that it took place. Now, it's got these things here that are called mutables. So mutable is like the anti-const keyword. So if you were to make a const object of type earthquake USGS, you would still be able to change the year, month, day, hour, minute, and second on it, and the date correct, true or false. So this seems like a really weird keyword to exist, right? But it makes sense if you understand that there are some data structures that will only store consts, right? Like the most famous being a binary tree, which is the next data structure we're going to learn. The binary trees that I use typically only allow you to put constant values into the tree. You can't change it once it's in the tree. And the thing is, like, sometimes, yeah, you do want to change things in the tree. Like, you know, the last time you accessed the element in the tree or something like that. And so if you do that, you can make those fields mutable. And mutable means you can change them even on a constant. So it's the anti-const keyword. And it does come up, actually, in situations like that. So we've got here, 7 member variables. And then if we scroll down to the public section, this is the interface. It's got a constructor, like you would imagine. Constructor does what constructors do. It's got getters, setters. See how it follows the same format as like what we do. Void, const reference. The getter is a const method, right? So just a bunch of getters and setters, and yeah, that's pretty much it. So it's, you know, it's basically a fancy pods. Okay. All right. So coming back down into here, now that we know what that is, data source is, like I said, that's the cool bridges thing that they made that will give you information on Shakespeare and earthquakes and whatever. So this function here that we called is returning a vector of 100 earthquakes. Then it converts this vector of 100 earthquakes into a linked list of 100 elements for you. You don't have to do this. It's nice. It's been done for you. So they don't have a list class or anything. They just build it up by hand. So they start off with head equal to null. And then they say for every earthquake and earthquakes, make a new node. Set the new node's next to be the head. So we're pushing on front. This is like an insert at front or push front function. So the new element's next is the old head, and then the head is going to move up to the new guy. And we just do that, and then at the end of the day, head is set to be the top of the list, the very last person in the bottom of the list. Their next is set to null, because it was null originally. So we got to work in singly linked list. Easy. So this code takes a vector and turns it into a singly linked list. Okay, and then this, we'll talk about this in a little bit. So your code's going to look a little bit different. I actually refactored it since I sent it out to you. If you look at your code, it uses like a while loop. So it sets current equal to head, and then it has a while current is not null. And then at the bottom of the while loop, it does current equals current points to next. So I just was like, well, that's just our standard list traversal algorithm, right? Like, we've gone over this algorithm a lot of times, this loop. This is how you loop over a linked list, starting at the head until our temp pointer gets null, go to the next, yeah. And then it's going to call set properties on that node of the list. And set properties is the function you're going to be writing. So you're not building a linked list, you're using a linked list for this assignment. It's actually substantially easier than the EU4 assignment. Okay. And so if we come up here to set properties, this is the first half of the assignment, and it should take you ideally about 15 minutes to do. I've linked to you some documentation if you want to read all about the singly linked element class. That thing here, the SL element class, is basically what I call a linked list node. Like it's just a single node in a linked list. And so it grabs the size of the earthquake. Oh no, that's the earthquake. It grabs the location of the earthquake, and it grabs the magnitude of the earthquake. And then your job is to change the visualization of it. So there's 3 things you have to do. If you read the README file, it goes into the details on it. But there's 3 things you have to do. First is you have to set the size of the earthquake based on the magnitude. And we'll talk about that in a little bit. Right now it does a random size. So this is wrong. The code works, but it's wrong, right? Currently, all of the nodes are colored red. That's also wrong. What you want is the coloring to be based on the magnitude. So yellows are 2s, greens are 1.5s and ups, reds are 4s and ups, things like that. So in the README file, it tells you how to color it. I'm not going to tell you how to change the color from red to green. I will leave that on you to figure out. Yellow might be too difficult for some of you, but I have faith. You're college students. You should be able to figure out how to change the color to yellow. I don't know. We'll see. See how it goes. I know, it's a mystery. And if you actually want to read the documentation on it, it's right here. You can read the documentation. But it should be pretty self-explanatory. So set the color based on the magnitude. That's how you get the magnitude right there. And then set the shape based on the location. If it's Hawaii, you set the shape to a cross shape. Let's see. Yeah, there you go. So if you if the last word in the string is Hawaii, then you set the shape to be cross. You set it to diamond if it's from Alaska, and you set it to circle if it's from anywhere else. So there's 3 options: shape : diamond, shape : circle, shape : cross. And again, I'll let you figure that out. It's in the documentation. So that should take you about 15 minutes to do. The hardest thing is just getting the last word of a string. Some people don't know how to do that. So I made a ends with function for you. So you pass in a string and you pass in Hawaii, and it returns true or false if that string ends with Hawaii. So there you go. Easy. So that's half your assignment right there. Okay. The other half is doing a little bit of what you might call stats on it. Okay, a little bit of data science right here. So too many colors. It has shapes too. Yes. Have you seen the thing where the person's like putting the shapes into a box? What meme is that? Yeah, this one. I don't know if I'm going to demonetize. I'm going to pause. Yeah, funny. Okay. So, work smarter, not harder. Yeah. Okay, so the second half of the assignment is you're going to be computing the mean, median, and mode of the earthquakes. So you're going to be taking the magnitude of the earthquakes. So you're going to be taking the magnitude not rounding. I think you're going to be flooring it. You're just converting it from a float to an int. So 1.5 becomes a 1, 2.2 becomes a 2, I think. And you're going to output the mean, median, and mode. So mean is the average. You just add together all of the magnitudes of the earthquakes, divide by the size, call it a day. Pretty easy. The median is the middle element in a sequence. So mean is the average. So 1 plus 2 plus 3 plus 10 is equal to plus 4 plus 10 is equal to 20 divided by 5 is 4. No, that's not right. 10, 20, 20 divided by 5 is 4. Is that right? Okay. Median is the middle element. So 1, 2, 3, 4, 1 million is equal to 3. because it's the middle element. Okay. So with so you can actually get substantially different numbers here, right? So let's actually do this. Okay. And then mode is the most common element. So with 1, 1, 3, 4, 1 million, the mode is 1. Okay. So you can see that these things give quite different answers. And when I was a kid, I always liked averages. Like averages made sense to me. If you've got a bunch of people in this classroom, and you want to figure out their average income, you just add up all their incomes, divide by the size of the classroom, call it a day, easy. But what I found as I started working in stats is that the mean is actually sort of deceptive at times. Like if Jeff Bezos walked into our classroom, then it would be like, congratulations, the average income in this classroom is now $200 million. Right? Hang on, somebody's at my front door. Be right back. There, let's resume. Are we using integer division? No, but you're going to round all of the earthquakes to integers. And by round, I think you floor them. So 5.9 becomes a 5. So if you have a median, yeah, I believe the average of the two middle elements is the median. So like if it's an even number, then you would average 3 and 4 together and get 3.5. So and that's it. That's the entire assignment. You have 9 days to do this. It's frankly, you know, the part with the coloring and stuff like that, it's probably less than an hour. I would say it depends, you know, half an hour maybe, something like that. And then depending on how quickly you can do the mean, median, and mode, you'll be done. That's a whole programming assignment right there. Boom, easy. So computing the mean is pretty easy. You just add up all the numbers and divide by the size. There you go. There's the average. Again, this is floating point numbers, not floating point averages, not integer averages. 3.5 becomes 3. That's correct, yeah. Median is less vulnerable to outliers like this. So if Jeff Bezos walks into the room, the median income only goes up one step, right? Like one to the right, you know what I mean? And so median numbers are actually really useful. Because like if you ask what is the median income, you're asking what is the income of the average American, right? Which is different from the average income. The average income and the average American's income are not the same because of things like this. Like Jeff Bezos would way throw off the average income. But if you say what is the income of the average American, you end up getting a quite reasonable number, right? And then mode, I never understood mode, or like why you would want something a la mode other than an ice cream. And then I started working like in what you might call data science, even though it's kind of a lightweight in the field. I did something called evaluation, which is like looking at programs by the government and others, but mostly government programs, to see if the government was getting its money's worth. You know, so if the government gives $1 million to promote this, how much is it increasing? How much does the needle move? How much does the average go up? And so after I started working on that, I started understanding mode a little bit better, like why mode is important. And mode is the most common answer, right? So let's say that we were polling people today on their thoughts on the Ukraine crisis. You know, I ask you on a scale of 1 to 5, how scared are you? The World War III is about to break out, right? And you might get an average of like 2.5, and you might get a median of like 2, but the modal response might be 5, right? Which means the most common response given was 5, you know, and that's a different question than mean and, you know, median, right? Mean and median are like you average all the numbers together, but mode is like, what's the most common response we got? And so you'll see in a lot of scientific papers, they'll say the modal response on this was 3. The modal response on this was 4. And that's interesting because like it's the most common answer given on a question. It's the modal response. So to compute this in code, the easiest way of doing the median is just to sort it. So what I would suggest doing is up here. Oh shoot, we're almost out of time, aren't we? I have to shake my phone to turn it off. Okay. To do the median, the easiest way is just to sort it. Just call it vector sort. It's 100 elements. Who cares? Sort it from beginning to end. And so basically, what I'd recommend is doing something like this, right? So as you're iterating across your thing, doing the set properties thing, I would just do something like this, where you're just like getting the magnitude of each earthquake, converting it to an integer, putting it into a vector of integers, and then down here doing the stats on it. So maybe call sort on it. Sort, grab the 2 middle elements, average them together. That's the median. Done. For mode, you're going to count how many times there's a magnitude 1 earthquake. You're going to count how many times there's a magnitude 2 earthquake, how many times there's a magnitude 3 earthquake. And you can do that a couple different ways. You can just write a loop or something. There is a std count is a thing. So you can count how many times, like here's your numbers. How many times you put in 3 there, it'll tell you how many times 3 is in the vector. Okay. Put in 4 there, it'll tell you how many times 4 is in the vector. Or you can just write it yourself. It's all these things are like they're not too much code to write if you want, but yeah, so you just count how many 1s, count how many 2s, and whichever one has the highest count, output it, and you're done. You have 9 days to do this. It's partly because I'm going to be gone. I'm going to the world's largest computer science educators conference next week. I'm going to be in Rhode Island from Wednesday through Saturday, I think. And new Zybooks? No Zybooks for the week. Or at least not yet. So, earthquake magnitudes range from 0 to 10, yeah. So that's it. You just print out which earthquake magnitude is going to be the most common. And if you just print out 1, you're going to be right every time. Are you presenting there? No, maybe. The Bridges people are doing a presentation, and I might help out. I don't know yet. Like they said something about me, like, I don't know. We're going to hang out and we're going to figure it out. So I might not. Nothing planned, nothing formal. Yeah. So I'm gonna go. Kearney's got to present his paper. Walk in there like, I know you rejected this, but you have to listen to me. You have to listen to me. C++ is not that bad. I'm telling you. Slam it down. So I'm going to be out of town Wednesday and Friday of next week. You'll have pre-recorded lectures to watch, is the plan. They have to listen. They can't ignore me. The truth is out there. Yeah, so there's going to be pre-recorded lectures next Wednesday and Friday. But that's kind of one of the reasons why I wanted to just give you kind of an easy assignment. Yeah, you use a linked list. You don't make one. So, yeah, it'll be due on gone, but I don't expect too many troubles with this one. U4's a lot harder. Okay, pretty cold in New England this time of year. Yeah, I was in DC over the weekend, and I was freezing. Of course, I got snowed on yesterday here in Fresno, so it's just too hard to teach. Don't make it easy to teach C++. That's impossible. Is Mankrelli teaching his no class? Yeah, it's going to be pre-recorded lectures. So maybe there's a chance that Lon might present instead. I've got to email him to the dean, but he's out of town until Monday. Yeah, I was coming out of the gym yesterday, and I'm like feeling these things hitting my head, and I look at my my car, and like there's actually like a little bit of pileup. Like it's actually like a little, I don't know, soft hail. I don't know. Like I'm not like a weather specialist, but it sure looked like I was having a little bit of snow building up on my on my car, which is kind of cool. There is no in-person class. No, it'll be all online next week. Wednesday and Friday of next week. I will be in person on Monday. Okay, so that's it. You got the stuff. I'll delete this, so it's not too easy for you. Yeah. Should be pretty straightforward. So good luck, and I'll see you all on Friday. Peace.